common myths about service mesh, eBPF, sidecars, ambient. Boy, that's a lot of stuff. I would say most common myth is that eBPF can replace sidecars. This is like a technical, we're getting into some of the technical weeds here. But eBPF is a very interesting kernel technology, right? Sidecars are, where you place your proxy. When you're talking about service meshes, you got to place a proxy somewhere. eBPF needs a proxy. So your choice is, am I using eBPF or not? And your choice is, am I doing sidecars or am I doing another deployment model? So it's a eBPF and or sidecars. It's not eBPF versus sidecars. So that's one big myth. Right? eBPF is a choice you can make. It's not a replacement for sidecars. I'd say another big myth, is that sidecars are heavyweight, and the sidecars are complex. Sidecars are actually, and I'm like the defender of sidecars now, because we looked at all these different models for Linkerd. Sidecars are actually the most simple deployment model you can come up with. One proxy attaches to every pod, right? Very clear, very easy. The proxy acts as the gateway to that pod. It controls all information coming in and out of it. And that sidecar can be very, very small and very, very lean. So one thing we do in Linkerd is we use a custom proxy called Linkerd 2 proxy that we built. That is extremely lightweight and extremely fast. And therefore, when you deploy one per sidecar, your total resource consumption is quite low. If you're using a giant proxy, then of course, deploying lots of giant proxies is large. So it's a trade-off in every dimension, but if you are interested in simplicity, right, which is kind of our goal in Linkerd, if you're interested in the simplest possible approach, then I believe sidecars are the right answer. What excites me the most about the service mesh ecosystem today, so there's a lot of interesting technology stuff happening, but what excites me is actually the business applications of the service mesh. So, I came into this as an engineer. As an engineer, you're always excited about the technology, but what I've realized over time is the service mesh eventually gets boring. Like every piece of technology, the goal, or at least every piece of infrastructure technology, the goal is to become boring. When you are boring, that is when you're not a source of problems, right? So the thing that excites me is some of the business applications we're now seeing as a driver for service mesh adoption. So for example, a lot of adopters of Linkerd are coming to the project because they want mutual TLS. Okay, mutual TLS gives you a bunch of things. It gives you encryption, it gives you authentication, it gives you a framework for authorization. But the reason why they're adopting MTLS is because they have compliance concerns, or because they have security concerns. So how do we make Linkerd solve not just the technical problem, not just the engineering problem of how do we deliver MTLS and rotate the certificates and all that cool stuff, but how do we actually solve the business problem of providing compliance, regulatory compliance and conforming to those guidelines within the Kubernetes cluster, and how do we prove to that? How do we prove that to an auditor? How do we prove that to someone coming into the system who's not a Kubernetes expert? That's the kind of stuff that excites me. The biggest pain points that enterprises go through when they adopt a service mesh is they don't have the right organizational structure to make this in place. So it's not a technical problem, it's an organizational problem. So when we see companies adopt a service mesh successfully, and we at Buoyant have been helping enterprises and organizations around the world adopt service mesh for probably 6 years at this point. So we're probably the world's foremost experts in this. When we see that happen successfully, it's because they have organizational alignment, which means they have a platform team, right? This is a team that owns things like the service mesh, owns Kubernetes, owns this platform, and they have a customer service mentality to the developers. So the platform owners are building this platform, they are delivering it to the developers, and they're serving the developers. And when you have that alignment and that breakdown, then the service mesh can be successful. Then you have a clear owner, you have a clear customer. When you don't have that, when it's done in a one-off way, or when it's, it's different teams and no one knows who owns it, that's when things go wrong. So the biggest challenges in monitoring and managing a service mesh are really the same as the challenges in managing and monitoring any other piece of software that has to run on your clusters. So, if you have a database, for example, and you run that in your environment, you can manage it yourself, or you can choose to use a SaaS database, right? And then someone else operates for you. Now, for a service mesh, you can't really do that because the service mesh has to live on your cluster, right? It mediates all of the RPC calls in between pods in your Kubernetes cluster. You can't have those calls go out to the internet and then come back. So if it runs on your cluster, that means someone has to be responsible for upgrading it, for knowing when it's healthy or unhealthy, for waking up at 3 in the morning when it breaks. So the biggest challenges are, how do I know how to do that? What are the things that I should be monitoring? What are the things that I should be thinking about? What are the things that I don't have to worry about? What does healthy behavior look like? These are all part of the operational burden of not just a service mesh like Linkerd, but any software that has to run on a cluster. And so that's a big challenge for anyone adopting a service mesh. You have to become familiar with it, especially if you're on the hook, especially if you're the one who's going to wake up at 3 in the morning. You have to be familiar with all of its operational characteristics. Now that's something that we can actually automate a lot with Buoyant Cloud, and we'll talk about that, maybe in another question. But a lot of our job at Buoyant is to make it so that Linkerd, even though it's simple, even though it's elegant, even though it's designed to reduce operational cost, how do we make that so it's actually something you can drop into an organization without having to hire a team of 4 people, without having to build all this organizational expertise? So we can actually automate a lot of that stuff. But like any piece of software, running software, especially in a fast-paced ecosystem like Kubernetes, is not easy. You have to stay on top of a lot of moving pieces. So how do we integrate the service mesh with our existing IT infrastructure? It's actually not that hard usually. At least the way we've designed Linkerd, which is the service mesh project that I work on, is we make it as easy to plug into the ecosystem as possible. So whenever we have a way of configuring Linkerd, or whenever we have a way of getting data out of Linkerd, we try and conform to whatever standards are out there, and that way you can kind of plug it into your existing tooling. So for example, Linkerd, one of the things that it does is it instruments every bit of traffic going through the pod, right? So if you're making HTTP calls or gRPC calls, we're measuring the request latency, we're measuring the volume of requests, we're measuring success versus failure. All that stuff gets instrumented by Linkerd, and then it gets exposed in this format, which we expose in a Prometheus compatible format, which is a common metrics format, right? So any data consumer which understands that format can just extract that from the proxies. On the Buoyant Cloud side, which is where we start consuming some of those metrics for our own kind of monitoring and management stuff, we produce events that can be plugged into systems like Datadog, or that can be plugged into systems like PagerDuty. So for example, Buoyant Cloud will look at the health of Linkerd across the entire platform, and if it knows that one cluster is having an issue, or something it's running out of memory in a couple hours it's going to crash, or you've got a certificate that's going to expire in 2 weeks, it'll generate an alert designed for the human beings to go remediate that situation. And that alert can be plugged into PagerDuty or into OpsGenie or into whatever SEIM system you have. And so we try and make those integration points as painless as possible. But what makes Linkerd different from every other service mesh in the market? This is a question I get asked a lot. And the easiest way to explain it is that it is the only service mesh that is focused on simplicity. Every aspect of Linkerd, from the underlying implementation all the way up to the way that you interact with it, is designed to give you simplicity. And by simplicity we don't mean, oh, it's a wizard, right? Oh, the wizard does everything and you don't know what happens under the hood. What simplicity means is operational simplicity. So that means Linkerd is something that you can understand. You can build a mental model for it. When it doesn't behave in that way, you can figure out what's going on. Every part of Linkerd is clearly documented. It's decomposed into these pieces that make sense. And every part of Linkerd can be monitored and managed in a very straightforward manner. So these are all things that are necessary, because the true cost of a service mesh, when you really adopt a service mesh, it's not the CPU that you're using, it's not the memory consumption that you're using, although we reduce that as much as possible, we minimize that. We have a very intelligent Rust-based proxy that does all this, is designed to use the smallest amount of memory and the smallest amount of CPU while still being as fast as possible. So that stuff is important, but the most important thing, the real cost, is the human cost. It is a human being has to be responsible for configuring this thing, for managing it, for monitoring it. We try and reduce that complexity as much as possible. So if you ask anyone, about the service mesh landscape, the number one word that's going to come to their mind when they talk about Linkerd is simplicity. We've talked a lot about Linkerd, so now let's talk about Buoyant Cloud. So Linkerd is a fully featured service mesh. Everything goes into the open source. We never hold back any features. Everything you have in Linkerd you can use to build a world-class, secure, and reliable system on Kubernetes. What Buoyant Cloud gives you is the management aspect of that. It's the automation aspect. So if you are running Linkerd in the context of a large organization, especially, you've got it deployed across 12 different clusters or 200 different clusters, what Buoyant Cloud allows you to do is automate all the management of that, including alerting, including health monitoring, including security, vulnerability notifications, including automated upgrades, so that you, as the operator of Linkerd, don't have to hire a team of service mesh experts to run Linkerd for you. You can automate almost all of that through software. So that's one part of it. The other thing that we do is we try and provide all the tools that you need to connect what Linkerd does, which is a very technological solution, to what the business needs. So for example, if you are using Linkerd because you are trying to implement zero trust network security, with microsegmentation, or if you're using Linkerd because you're trying to implement mutual TLS, or if you're using Linkerd because you have FIPS compliance and you're selling stuff to the federal government, we can provide you in Buoyant Cloud with the types of reporting and auditing and analysis tools that you need to ensure that the way you've configured Linkerd is actually meeting the business use case for using Linkerd. And so that someone who's an auditor, even if they don't know anything about Kubernetes, you can still show them, here's a report, look, we're conformant, everything's green, or you can do your internal auditing. Oh no, we need to fix this thing over here. So we want to connect Linkerd with Buoyant Cloud, and we connect it as close as we can to the actual business use case. So at KubeCon, we announced the release of Linkerd 2.13. This is a very big release. It adds two major features to Linkerd. The first is circuit breaking, which allows us to reduce traffic automatically to services that are failing, so we give them a chance to recover. And the other is dynamic request routing, which allows you to control the flow of traffic through Linkerd by HTTP verbs, methods, query parameters, or anything like that. That allows you to build very sophisticated systems like sharding across regions, or sticky sessions, or even A/B testing based on which user, which bucket a user is in. So that's a big announcement. With that, we also announced the introduction of FIPS compliant Linkerd, available from Buoyant, and we introduced a free tier of Buoyant Cloud that allows any Linkerd user in the world to connect their Linkerd cluster to Buoyant Cloud and get automatic health monitoring, security, vulnerability notification, and upgrade assistance. So it's a massive release for us, a lot of really exciting stuff, and really thrilled by the reaction from the community. So zero trust is the idea that instead of having perimeter security, so instead of having a firewall around our cluster and then letting everything within the cluster be accessible to anyone, we instead move that security boundary down to the smallest, most granular level possible. So in the case of Kubernetes, that's a pod. Right? So in zero trust, every pod has its own security boundary. Every pod is doing its own authentication, its own authorization. And it turns out that a service mesh is actually a great way to do that, because a service mesh will allow you to, by having a sidecar proxy, allow that proxy to be the entry point and exit point for all traffic to that pod. So that proxy, in the case of Linkerd, we have this very fast Rust-based proxy, simply called Linkerd 2 proxy. That proxy can do mutual TLS, it can do authorization policy, and it can provide a security boundary that's independent of everything else in the environment. And that's the core tenet of zero trust, is that every piece of communication must be authorized and authenticated every single time. And we can no longer trust the firewall with the soft, squishy center. We have to have security all the way through our stack. So Linkerd 2.13, which just came out, added some really exciting features to Linkerd, including circuit breaking and dynamic request routing. But in the future, we've got a lot more stuff coming down the pipe. So the things that we are looking at in Linkerd land include mesh expansion, which is the ability to run the Linkerd proxy outside of Kubernetes, including on VMs, on EC2 instances. So you have a mesh that's able to extend beyond the scope of the cluster. We're also looking at egress control, the ability to restrict traffic going out of the cluster using the same rich dynamic policies that Linkerd uses today, which are both on the gateway API. And we're also looking at ingress. So Linkerd can extend. Today, it works with almost any ingress controller that's out there. Linkerd itself can handle ingress traffic and can provide it the same unified gateway API configuration mechanism. There's a lot of other things we're also working on in the scenes, but those are three big ones.